First, what is thermodynamics? Thermodynamics is the study of change and transfer in the state of energy. Change in the state of energy. So let's say that we have, to understand this example, let's say that we have a wind turbine. So this is, just imagine this is a wind turbo, and then we have wind coming up to the wind turbo and spinning the motor. This will generate electric energy. So we can see that the energy is transferred from wind energy to electric energy. This is what the first law of thermodynamics says. The first law of thermodynamics says that energy cannot be created or destroyed, but it can change its state and transfer them into different state of energy, as we had this example. So we can see that the wind energy is transferred into electric energy. To understand different parts of thermodynamics, we have system. This is spelled wrong. System and surroundings. So the system will be the core idea that thermodynamics will be operating on. To understand this better, we're gonna use this example. So let's say that we have a kettle. This is a boiling kettle, and then we have this kettle. So the system is the kettle and everything that is inside the kettle, and the surroundings can be anything that is around the system. So this will be the system, and the surroundings will be anything. Surroundings will be the everything around the system. The other most common terms that is appeared in thermodynamics is exothermic and endothermic. So exothermic is the release of energy. In this case, the system will release energy, and this will cause a negative change in the internal energy. To understand this better, we need to look at the kettle as an example. If the kettle if we have boiling water inside the kettle, and it release energy, so the water inside the kettle will be cooled down, and this will cause a negative internal energy, because the boiling water has lost its heat molecules and it has cooled down. So this will cause a negative internal energy. Endothermic is the quite opposite of it. So in this case, the endothermic will absorb energy from the surroundings, and will cause a positive internal energy. To understand this better, just imagine that you are using a pot and you are boiling water. So the water will absorb energy from the surroundings, from the heat, and it will have a positive internal energy because the fire made the water hot. So the water has gained some energy, and that has caused a internal energy. That has caused a positive internal energy. In thermodynamics, we have this formula that is Q negative W, and so in this case, this is change in the internal energy. We can identify this by this is the heat energy, negative the work done by the energy. In this case, the heat energy is positive because the system has some energy, and this is the work done by energy. This is negative because the work is done by the system. and when the work is done by the system will obviously release some energy because there is no other energy to make the work done on the system. Next, we have the specific heat energy. Specific heat energy is the specific heat energy is the heat energy. The specific heat energy is the energy needed to raise the temperature of one kilograms of a substance by 1 Celsius or Fahrenheit. Not Fahrenheit, but I don't know what the K is. And then the formula used by this is Q is equals to MC change in T. And then we can see that Q is the heat energy. The heat energy is equal to the mass of the substance. This is measured in Q. And then C is the specific heat energy. Specific heat capacity, indeed, not the energy. And then T, this is going to be change in temperature. Change in temperature. To make this formula work, we need to change the formula. So we have Q is equals to MC T. And then to make this formula work, we need to make C equals to this formula. So we can divide this by the surrounding of C. This is going to be this. Change by T. Divide both sides by this. This is going to cancel with this. And then C is left is equals to Q is equals to Q divided by M, the mass, and then change by T. So the specific heat energy is going to be Q, which is the heat energy. The specific heat capacity is equals to Q, which is the heat energy. This is the mass in grams of the substance, and this is the change in temperature.